Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Good day, everyone. Welcome to attend today's AI for Good webinar organized in partnership with ZTE Corporation. My name is Wang Liang from ZTE, and I've been working with ITU for almost 10 years. I'm also the rapporteur for Question 21 Study Group 16, ITUT, which is a leading team for the standardization of multimedia area. And as we all know from a proof of concept to production, AI has become a very powerful engine for digital transformation. All things can be intelligent and becoming a very new vision for AI. AI for Good series provide a leading international platform for dialogue on AI. And today we have the privilege to invite the experts in AI area, and they will bring us the perspective of cutting edge technology for AI to the audience. And you can ask questions as short as possible in the QA tab below. And for this watch from Bilibili, CSDN, YouTube, or any other live broadcasting platform, please join the webinar here so you can interact with us. So let's welcome our first guest, Ms. Qin Sisi. Ms. Qin is from CAICT. She is a senior engineer of AI Department of Cloud and Big Data Institute. And also she is our international certified information system auditor, has more than 10 years experience in project and quality management in financial institutions, and has in-depth research and practice in CMMI, DevOps, and software effectiveness. As the leader of the MLOps group of the AI Engineering Promotion Committee, now she focuses on tracking the development of AI engineering. And today, her topic for today is accelerator of AI engineering, MLOps. And Ms. Qin, the floor is yours.
Okay, can you hear me? Okay, thank you. Hello, everyone. My name is Qin Sisi. I come from China Academy of Information and Communication Technology. And today I'm so happy. It's my pleasure to make this speech about MLOps. And so thank you very much for ITU and ZTE. So first, I use 1 minute to introduce myself. And I had more than 10 years experience of project manager and had in deep research in CMMI, DevOps, and software effectiveness. Now my work focuses on researching the development of AI engineering, and I lead the establishment, appraisals, and consultation of MLOps standards. So today the title of my speech is about the accelerator of AI engineering, MLOps. MLOps is attracting more and more attention, especially in China in these 2 years. And from last year, there were many companies and enterprises beginning or planning to implement MLOps for their intelligent transformation. So today I will talk about MLOps in 4 parts. Now let's begin the first part. Why is MLOps? As we know, artificial intelligence had been developed more than 60 years, but in recent years, great changes had been taken place in the AI field. AI engineering is more and more needed. People want to make more business value by using AI models or machine learning models at a larger scale. And from the experiment environment to the production environment is the only way which must be passed. And on this only way, we meet many problems. Such as the first problem is that machine learning projects cost far more than expected. Release a machine learning model usually needs dozens of days. Even some organizations need more than 90 days. So it's very, very horrible for any company. It means a big cost. And the second one is about model degradation, which is a birth defect. Because of the long life cycle and the model drift, the quality of the inference serving cannot be satisfied. The data is always changing. If we cannot update the model, the inference serving is useless for the business. And the third problem is that managing the whole life cycle is very difficult. Because of the digital assets are complicated, the assets include like code, data, algorithms, models, etc. And this is the big difference between AI project and the traditional software. So how to do the unified version management and the traceability for those assets is very important. And the last one is about the cross-functional collaboration. This is very difficult because the AI gap between the data scientists and the operation teams is very difficult to close. So how to solve these problems and how to deliver AI models from research to production faster and with less risk are the hot topic in the AI industry or in the AI engineering industry. However, MLOps just can help to solve these problems and accelerate AI engineering developing. So the next part is about what is MLOps. The appearance of MLOps looks much like the appearance of DevOps. Several years ago, the DevOps appeared for improving the productivity and reducing costs of traditional software. And now MLOps appeared for improving the productivity and reducing costs of machine learning software. They look the same. However, they have big difference between them. The process to produce a machine learning model is complicated. The MLOps includes machine learning and DevOps, and machine learning includes data, code, models, algorithms, etc. So some institutions or collaborations said that MLOps is a kind of culture or a set of practices or best practices or a set of workflows. They are all correct, I think, because the core of different definitions is consistent. And so in my opinion, MLOps is a set of management system which connects all roles and teams to establish a standardized, streamlined, automated, and integrated machine learning lifecycle management system to enable the organizations to drive the business value, the cost saving, and the higher efficiency by using AI capabilities. So what about the relatives between the MLOps and AI engineering? This year, Gartner said that AI engineering includes data ops, MLOps, and DevOps. MLOps is one part of the AI engineering, and this is one hand. But on the other hand, after visiting many companies and enterprises this year, I think MLOps is more and more extensive extensive scope, such as model ops, future ops, some parts of data ops, and model governance, model security, etc. And I think computing capability, storage, infrastructure, and some other technical support are the basement for the AI engineering. So MLOps is very important for AI engineering and is the accelerator of AI engineering. So now let's talk about the history and the trend of MLOps. Since 2015, MLOps came out from a paper in Google because of so much hidden technology that in the machine learning systems should be solved. And MLOps just can't do it. So MLOps had been developed very, very rapidly. Even our CICT had published the first standard of MLOps this year in order to standardize the industry and help the industry to apply MLOps more smoothly. And in the next 3 to 5 years, MLOps will reach its peak. There will be 60% of Chinese enterprises developing and operating the ML machine learning projects by using MLOps. And also the tools market will increase rapidly. Okay, let's exactly analyze what is the value or benefits of MLOps. I think there are 4 words: greater, faster. In Chinese is 多快好省. Greater actually means more and more models are released at a large scale, which can speed up AI industry developing. The models can enable more business scenarios. And the second is faster. It means the life cycle of AI model is more and more efficient by rapid iteration, which is easier to develop and deploy AI successfully. The third one is better. The quality of AI model is better, which can drive more impactful business value. And third one is, and last one is less. Labor cost is less because of the automated pipelines in MLOps. AI engineers or data scientists no longer have to deal with tedious model training, model maintenance, and model updating. They could have enough time to concentrate on the research or other more valuable work. So why the MLOps has so many benefits? That's because the MLOps contains many excellent concepts which are recognized widely, such as CI/CD. It means continuous integration and continuous delivery. Through the continuous integration and deployment, we can deliver the model serving easier, more smoothly, and efficiency. And next is CT, it means continuous training. Continuous training includes model training at the experimental phase, and the online phase is the key step for model maintenance. And next one is CM, means continuous monitoring. It focuses on the performance and the efficiency of the model, the results of which are the triggers for model updating. And next one is pipelines. The whole lifecycle actually is a long pipeline, within which is a series of many mini pipelines. And last one is automation. Automation is the basement of the pipelines running. Now let's look at this picture. This picture is the whole life cycle of MLOps. We can see that from the requirement phase, which is the first step, to the last phase, the machine learning projects may at first seem a lot like a software development project. Their path and the structure are more closely, but let's look into the details. In the development phase, we should code and process algorithms, which coding includes data processing code and training code. That's more complicated length of the wheel development. And in the testing phase, we should not only do the function testing, such as the model serving testing, we also should do the model evaluating. And in the deployment and the release phase, we should consider the updating strategy, such as grayscale release, blue-green deployment, rolling release. And meanwhile, we can do A/B test or other tests to ensure model performance in the production environment. Because although we have done enough tests in the test environment, the performance is enough excellent and satisfies the requirements. When we push the model to the business online, there may be a surprise for you. The performance online may not satisfy the real requirements. So in the operation phase, it's the end of, it's very important because it's the end of only one cycle, but also it's the beginning of another cycle. So we should monitor both the model and the business and collect the feedback, then decide that when we should roll back or redeploy or retrain the model, and this process should be continuous. So depend the MLOps life cycle. Our CICT had started to organize the making MLOps standards. We have done the framework of series of the standards, which comprises 7 sub-standards. You see on this picture, the first 3 standards are about the machine learning projects processing, including development, management, model delivery, model operations. Then the next 3 standards are about model ops, which focus on the model governance, including model management, model security, and risk management, and the organizational structure. And the last one is about the tools capability for the manufacturers. And the first standard was published in April this year. It comprises requirements management, data engineering, and model development. The second standard is model delivery, which will be published this month. It comprises building and integration, deployment and release, model testing, configuration management, measurement, and improvement. So the capability maturity is divided into 5 levels. The 5 levels corresponding to different levels of enterprise capability of machine learning projects development and operations. So from level 1 to level 5, it shows the higher and higher degree of automation capability. So how about the MLOps practices? Before we produce the models in the laboratory, it doesn't matter if the process is standard or not. But now we produce the models to be used in the online environment for the business. It's very important that if we have a unified and standard process, and meantime, the market for AI is changing. The focus has shifted from companies that have the technical expertise to build models to the others that use AI solutions powered by those models. So MLOps is what an AI project should look like, I think. And through the practice, the efficiency had been greatly improved, such as a company which we had visited. The efficiency increased nearly by 14%. And MLOps not only can enable technology department directly, it also can enable a business department directly. And at the developing of the MLOps practice actually has 4 parts. In the first stage, model development has been practiced commonly already. And the second stage is in progress because model delivery is very hard. It's harder than the first step. And most of the company's capability of continuous delivery is not mature. And the third stage is even harder, which is under planning in many companies. So model operations should be pushed. The first stage is about AI assets, which is a new focus. The risk, the security, the traceability, the version of the assets are more and more important because of the increasing quantity of models, and especially in the financial industry. So in summary, model development is no longer the key focus, but an integral part of the process of deployment, maintenance, and governance of models. So this page is about MLOps market. MLOps market is always active, and there is a plethora of open source and paid MLOps tools available today. And the tools market can be divided into two categories. The first one is the end-to-end MLOps platforms, which is large and comprehensive. On this platform, we can find many functions to produce and maintain the models for the whole life cycle. But only some big name companies have enough capability to build the end-to-end platform. Then the other more companies or enterprises prefer to build specialized tools for some special business scenarios. For example, there are many tools offer, such as workflow, data version management, metastore, experiments management, machine learning observability, and future store, etc. Then, as an organization which wants to implement MLOps to improve AI capability, and how to choose a platform or some tools, it's a question. In my opinion, there is no one platform or no one tool chain can satisfy all needs of all the organizations. So the organization should comprehensively consider AI project needs, organizational structure, AI strategy, planning, existing technological assets, and some other special things. No matter what suits you is the best. So at last, let's talk about the prospects. First one is more about model governance. Model governance is more and more important. Next one is digital assets. It includes features, models, data, pipelines, etc., and need to be centralized and unified in management. And the third one is trustworthy AI. It make AI more making AI more expandable, fair, robust, private, and transparent is an important direction.
Hello, Ms. Qin. Yeah, I think we have some problems to connect with Ms. Qin. So, yeah, maybe she's offline.
Yeah, perhaps. I'm not sure what's happened, but if anything, it will be her connection.
Yeah. So for the audience, we should take maybe 1 or 2 minutes for the speaker, Ms. Qin, to come back with us. Thank you.
Perhaps in the meantime, would you perhaps want to move on to our next speaker? And if she makes it back, then we can obviously finish off her presentation. What do you think?
Yeah, that's okay. So let's move to our second speaker. Yeah, okay. So our next speaker, I'm happy to invite Dr. Lu Mian. And Dr. Lu is our system architect and also the manager for the database and HPC teams in Full Paradigm. He obtained the PhD degree of computer science in HK University of Science and Technology. Focuses on the research of database and heterogeneous computing. He has published more than 20 academic papers in the top conferences and journals. His current work in Full Paradigm is leading the team to build high performance and scalable AI infrastructure for real-world applications. He's also the tech lead of the open source project OpenMLDB, which provides a real-time future platform for machine learning application. And the topic Dr. Lu will share with us today is OpenMLDB, a real-time future platform computing consistent future for training and inference. So Dr. Lu, are you ready? The floor is yours.
Yes. Yeah, can you hear me?
Yeah, I can hear you.
Okay, let me share screen.
Okay. Yeah, we can see your screen. So yeah,
okay.
Go ahead and the presentation.
Okay, let me get started. Okay, thank you very much. Thank you for the invitation. Yeah, it's my pleasure to introduce OpenMLDB here. I believe in the last talk, the speaker introduced some concept and value about MLOps. So in this talk, in my talk, I will introduce a very specific component that is to do the feature engineering for the MLOps. Yeah, so this is my topic. I will introduce the OpenMLDB and open source enterprise-grade real-time feature platform. Here is a little bit of my background. Yeah, so yeah, I'm working in Full Paradigm, and yeah, I'm also the tech lead of the open source project OpenMLDB, and I got my PhD from the Hong Kong University of Science and Technology. Okay, here is the content of my presentation. And first of all, I will introduce the challenges of real-time feature computing. Then I will introduce the solution that is open source solution, OpenMLDB, how to tackle the challenges of this real-time feature computing. And the last, I will probably introduce a bit about the open source community for the OpenMLDB. Okay, first of all, maybe I talk about some background of the machine learning development. Yeah, this is probably like the life cycle to develop a machine learning application and then deploy it to online. I believe most of you, as long as you have some experience of the machine learning application, probably you know usually we have such kind of two process. So one process is we do the offline development. That is, we have the data scientists. They will do the training and do the feature engineering based on the offline data. Then they will deploy the model to online to do the online serving. So today, my talk will be very focusing on the feature. Yeah, the highlight part is the feature part. So the feature is here the information in this process will convert it from the data to feature to models. So the feature is we are talking about is do the feature engineering to generate more meaningful data and feed it to the model for the training and the inference. Okay. So the next one is a little bit more background is like the why we need the real-time features for the real-time decision making. First of all, I think we all know that we have the two categories of AI. One is about the perception. Perception is like we are talking about the computer vision, like the natural language processing. All these kinds of applications are about the perception. And another kind is like the cognition, or we are talking about like the decision making for especially for tabular data, such kind of application like the anti-fraud, like the personalized recommendation, like this kind of application. And when we talk about the real-time features, so what exactly does the real-time mean? So I think we can explain the real-time features from 2 dimensions. One is we need the real-time data. This means that we really need the fresh data. We will compute the features based on the fresh data, not from the data of the last year or even last month. But we need data from the data happening, the behavior happening in the last few seconds. This is we are talking about the real-time data. The second thing is we talk about the real-time processing. So the real-time processing is we really need the low latency to compute the features. So here the example is like we have the real-time anti-fraud. So this is actually one example from one of our customers. They need the real-time anti-fraud, and they need the low latency. It's like 20 seconds, 20 milliseconds. And today, actually, in the market, we have quite a lot of solutions to do the data processing or for the feature engineering. But actually, we see that most of the solutions are based on batch processing and streaming processing. And like the most streaming processing solutions, like the Flink, like the Spark, actually, they are not the hard real time. The latency is still like a few seconds. So for many applications, like the anti-fraud, like the recommendation, like driverless cars, we actually really need the hard real time to do the decision making. So we do need a good solution, a better solution for this hard real time feature engineering for the real time decision making. So here is an example of the what is the real time features for the anti-fraud. For example, we have a transaction, a credit card transaction. This is the original information from the credit card, like the card number, the transaction amount, and the timestamp, right? And based on this original information, actually, we cannot do the inference directly. Usually, we need to have a feature engineering that is together with some history transaction or other tables from the database. Then we'll together with this information, we will do some feature processing or do some feature extraction. So mostly the feature extraction, like we will put the current transaction virtually into this table, and based on the timestamp. This is very important because most of the feature engineering actually is based on time series data. So we were based on the timestamp, and we will have a time window. For example, here we have 2 time windows. One window is 10 seconds, another window is like 3 hours. Then we will base on this time window to do some window-based aggregation. For example, we will have some extracted features like the max and the mean, like average of the transaction amount over the last 10 seconds or over the last 3 hours. This is like the extract features for the original information. Then we got this information, we will feed this result to the models to do the inference. So this is like we have the process of the feature engineering. So we can look at this one and what's the engineering requirement for to implement this feature engineering platform. The first one is very important, is like the correctness. That is the online-offline consistency. I will talk about this more later. And the other one is more obvious. That is because this is a real-time system. So we need the low latency, we need the high throughput, and we need high availability. These are all very important engineering requirements for an online service. Okay, now look at the challenges. Why it is a challenge to construct a feature platform, especially for the real-time computing, real-time feature computing. Okay, so here we have the workflow. Actually, today we see a lot of examples from the community. Actually, most companies, they are still in follow this workflow to do the feature engineering. Yeah, and also actually without OpenMLDB, for Paradigm also follow this kind of pattern. Yeah, let's see what is this pattern. Yeah, the first of all, when you decide to develop an machine learning application, first of all, we will have the data scientist. So the data scientists, they will have the background of machine learning, right? So they have the domain knowledge of machine learning. They will know how to build the features, how to choose the models, how to choose the models. Basically, they know the algorithm. Yeah, so they will use the Python, they will use the SpikeSQ and do the offline feature extraction. And then they will go to the offline features and then do the training. Then their job will be done as long as the model, the quality, or we can say the accuracy is good enough. Then their job is done, right? But the problem is they don't care about the online inference. Yeah, they don't care about the performance of their feature engineering script. This is usually implemented by Python or by SpikeSQ, but Python and SpikeSQ, they are not good at the low latency, right? So if you directly deploy this script online, then the latency will be the latency, the throughput, and even the high availability, they all cannot be guaranteed. So at this point, usually we will have an engineering team. So what is the work of the engineering team? So actually, they will look at the feature extraction script developed by the data scientist, and then convert it to a more efficient program using database or using C++, and make this component is really efficient. It really can deliver like a low latency, like high throughput, like have the high availability for the online service. Yeah, this is very important. Only you can meet this engineering requirement, then you can have this system online. Then you can do the online service. But the problem is, we already can see one problem here is we need two teams, right? Not only one team, not all data scientists, they finish their job, but they cannot do this online, cannot do this implementation for the online service. So we will have two teams. So this means that the effort actually is quite a lot. Then another thing is actually this is not the end. There's another very important problem is we need to guarantee the consistency between the offline feature extraction and the real-time feature extraction. This means that the program implemented by the engineering team, including the data definition, including the computer logic, should be exact same as the one developed by the data scientist, right? So how you guarantee this? You have to do the verification. You have to do the testing. Actually, this is cost a lot. And don't think of this is like a simple problem. This actually costs a lot. Yeah, the two teams need to sit together. They need to communicate. They need to develop, iteratively develop, and then test. Based on the experience of four paradigms, this is for a very large project. This usually takes a few months. Yeah. Yeah, this is like some reasons why it will produce like inconsistency. One reason is we have like the different tool capabilities. Like the scientists, they will use like Python, but for the engineering team, they will use C++, right? And MySQL, this is probably they are two different tools. So you need to make them they deliver the same logic. And the other thing is like you have the different understanding, like for the data definition. This is like the one engineering block from US online bank, Varo. There is one block describing this issue. When they're talking about like the account balance, yeah, this is like a simple definition, but this is the understanding from the two teams are different. Yeah, for the data scientists, they think about they use a relatively simple definition like the account balance as of yesterday. And for the engineering team, they think about the account balance should be the real-time account balance, right? So this will be actually cause the inconsistency of the online and offline. So now at this point, actually, we can already see some problems of such kind of development process that we need to have two groups of developers with different skill sets, and we also need to maintain two systems. And also, the more important thing is we need to do the consistency verification. So the cost actually is very high. Yeah. So today, actually, I will introduce like the OpenMLDB. OpenMLDB is we have an open source solution, have a feature platform to computing consistent feature for training and inference. So first of all, is a little bit project background about the OpenMLDB. The background is the OpenMLDB project actually is initialized by the Four Paradigm. Four Paradigm is an AI company. We are focusing on the offering platform-centric AI solution. And OpenMLDB actually is used by Four Paradigm as a commercial MLOps product stage, used to define and compute real-time features. OpenMLDB actually is open source last year, but you look at this picture, you will understand that before open source, actually we already have some we have the development for almost like 4 to 5 years. Yeah, so before open source, OpenMLDB is integrated into the commercial product, and they have quite a lot of customers for the Sage platform, like the ICBC, like the Young China, quite a lot of big companies. And after open source, we also got quite a few users from the community, like the Huawei, like the Jingdong, like the Akulag. We receive quite a lot of comments from our users, so we really appreciate their support. Yeah, so now let's talk about the architecture of the OpenMLDB, how OpenMLDB solves this problem. First of all, this is like a very high level architecture of OpenMLDB. So we look at the inside of OpenMLDB, we will see that we still have two engines. One we call like the batch CQ engine, and one is the real-time CQ engine. So the batch CQ engine actually is improved based on Spark. We actually do quite a lot source code modification to improve the efficiency and enhance the capability of Spark. So we call it like a Spark++. So the batch CQ engine is for the offline development, and the real-time CQ engine. This is actually a time series database. This is actually built from scratch by our team. This is really focusing on the time series data and really optimized for the feature engineering workload. So this is actually we also offer two storage engines. One is really for efficient. That is actually based on memory, and another one is based on disk. That is for low cost. Anyways, the real-time CQ engine is for the online inference, for the real-time feature computing. So this can deliver the low cost, like the high throughput, and also the high availability. Now, another very important thing is how we make the result consistent between these two engines. We have a unified CQ plan generator between these two engines. This unified CQ plan generator is trying to bridge these two engines, and they make sure the same CQ when the same CQ coming, I will generate the CQ plan for the batch engine, and as well as for the real-time CQ engine, and these two execution plans actually will be consistent. So based on such a kind of architecture, so we only have the CQ as a programming language for the developer. So this means as long as the data scientist, they can have the capability to write CQ to do the feature engineering. Then after they finish their development, they can immediately go online without effort from the engineering team. So yeah, this is actually summarized. We have 3 steps from development to deployment. That is, data scientist write the CQ offline, then we have to use one command to deploy this CQ to online, and then we also import the real-time data. Then that's all. This means your feature computing service is already on, and you can do the real-time feature computing. So this actually compare with the previous two separate process. This is really save a lot of cost. Okay, this is like summarize the workflow. Actually, I just introduced. Like first of all, they have the data scientists. They will be at offline model, and they will do the offline database. They import the offline data. But this is actually can be a soft link. So this is not a real like hard copy. Because the offline model actually is based on the Spark. So as long as you can provide like HDF path, so we can do the computing based on the HDF files. Then you will do the offline feature extraction, then do the secure deployment. Then you will change it to the online model. For the online model, you will import the data and make the data ready for the online for the real-time data. Then this means you already have the computation logic, and you also have the data ready. So this means the service is on, so you can serve the request at real time. So to summarize, actually, OpenMLDB in trying to tackle one challenge is to provide the consistent features for training and inference. And we also have one very important characteristics is we have the capability to compute real-time features in just milliseconds. This is actually very important and make us the project is different from many other feature stores. Okay, now I will just quickly go through some of the highlights of the products, and I will not talk about the detail. If you are interested, you can contact me offline. Yeah, the first one is like I just talked about. We have a unified execution plan generator. So we will have this one to produce this consistent secure plans for the offline engine and online engine. And the second one very important is how we guarantee the efficiency of the real-time feature, computing. That is actually I just mentioned we build this real-time engines from scratch. So this actually we listed two very important key optimization techniques. One is we are building an optimized data structure that is a double layer skip list. This is actually in memory. This kind of data structure is really optimized for like the time series data. This is really efficient if we want to fetch some data over a time window. Yeah, the second thing is that we have the pre-aggregation. The pre-aggregation actually means that when your the time window is very larger, like you have millions of data in a window, if you just do a real-time computing, actually the latency will be high because there are too much data, right? So here we actually do some pre-aggregation. This means like you have some, for example, you want to compute the total clicks over the last year. So actually you can pre-compute the clicks, the total number of clicks of each month, right? So you can pre-compute some results, and when in the online, you just can accumulate the result from the pre-aggregation, the pre-aggregated table, and plus the real-time result. So based on these optimizations, actually we compare with the first figure is we compare with the commercial in-memory database. Actually, one is the SAP HANA, and another one is the single store. So we can see that for the time series data for the feature computing workload, so OpenMLDB actually can outperform these two commercial database a lot. Yeah, so the second row actually is like the performance improvement by the pre-aggregation. We can look at like with the pre-aggregation, the performance can be improved quite a lot, like 100 times. Actually, for these technicals, we also have a paper published in the top academic database conference, MLDB. If you are interested, you can look at our paper. Okay, the third thing is we have the Spark version. As I mentioned, our offline engine is based on Spark, but actually we are not using the community version. Actually, we have done a lot of things to deliver a tailored Spark backend for the OpenMLDB. We have do a lot of organizations to improve the performance. Yeah, I will just skip the detail here. And the fourth thing is we are doing the secure extension for the feature engineering. Because the feature engineering, they have some unique features. They have the standard secures probably is not good enough to compute these features, or it will be very complicated. So we actually extend the standard features, the standard secure. We introduce like the last join, like the window union. Window union actually is like the window aggregation across two tables. This is actually very, very common for the real world applications. Like the window union actually is also can be implemented by standard secure, but the secure will be very complicated and the performance actually is poor. So we enhance the secure and to make it better for the feature engineering. The next thing is we actually have the secure-centric development and management. This is like a OpenMLDB CLI. This CLI actually is very similar to the MySQL CLI. You should be very familiar with it. The last thing is that we are delivering an enterprise-grade feature platform. So we have quite a few important features for the enterprise applications, like the high availability, like the horizontal scaling, like the smooth upgrade, like we have the monitoring system and the multi-class support. Yeah. So actually, as I mentioned before, we open source. We already deployed this product in hundreds of real-world applications. Okay, this slide actually shows the after open source. Yeah, all these work are done after open source. We are trying to integrate the OpenMLDB to the MLOps ecosystem, right? So actually, the OpenMLDB actually we have done a lot, quite a lot of work. Like we developed the connectors to import the online data source and offline data source. Yeah, we are also trying to integrate OpenMLDB to some production ops. Like we can right now we have integrated OpenMLDB to the Airflow, to the Dolphin scheduler, and we also providing the monitoring solutions based on Prometheus and Grafana. Okay, lastly, I will probably introduce a little bit about the OpenMLDB history. Yeah, this one I already mentioned. We actually open source last year. So yeah, it's like a young open source project. But actually, before open source, we already done quite a lot of development and quite deployment. Yeah, and after open source, we also got some got a lot of feedback, and quite a few users are also trying to use our project to deploy their MLOps. This is just like one use case is like Akulaku. So Akulaku is an Indonesia fintech company. This is actually our first users from the community. Yeah, they are trying to build an MLOps platform and to serve the application like the anti-fraud, like the recommendations. Yeah, so they are using actually their requirements quite match our OpenMLDB. Like they need the low latency, like the high concurrency, like the feature based on fresh data. Yeah, this is all OpenMLDB can do. And then they choose OpenMLDB to make as a feature platform for their system. And their scenario is try to real-time processing for orders within a day. So they will have probably like the 1 billion orders per day. And so finally, they got the latency like it's 4 milliseconds. This can match their, can meet their requirements. Okay, now this is like the numbers of the OpenMLDB community. Right now we have the 1 year old. And today, actually, these numbers actually are a little bit out of date. It's like 2 months ago. Yeah, today actually we have more contributors. Yeah, And today we have the 0.6 version. Okay. Okay, I think this is pretty much about my sharing. Yeah, if you are interested, you are very welcome to join our community. And we have the website of the OpenMLDB and our WeChat group. And this is also my personal WeChat QR code. I'm very open to discuss with you for any problem, for any issues, or any suggestion. Thank you very much.
Okay, thank you, Dr. Lu, for giving us the brilliant talk and so many important aspects of OpenMLDB. So, yeah, I'm gonna ask the audience about the questions for this topic from Dr. Lu. Okay, so I got one question from the audience for Dr. Lu. In OpenMLDB ecosystem, what are the challenges or what we should pay attention to when combining OpenMLDB with DataOps and MLOps tools to build an end-to-end MLOps pipeline? So, Dr. Lu,
yes,
could
this
you
is a very
answer this question?
Yeah, sure. Yeah, this is a very good question. Actually, we also noticed today we have quite a few community users. They are trying to integrate our OpenMLDB into their MLOps. So actually, we really suggest that when you have like the data ops, we really suggest you can look at our connectors. So today, actually, we already have the connector for Kafka, for the Pulsar, for RocketMQ. Yeah, these connectors are ready. This connector will really, they are actually will be really helpful to help you reduce the cost to do the connection between the data ops and the feature ops. Yeah, I think you can try this one first. If you have any feedback or suggestion about this functionality, you can contact me. Yeah, and for the model ops, actually today we are not doing this is like the loose integration because all the inputs for all the output from the OpenMLDB are quite standard, like the CSV or Parquet. So the model ops can, the models like the different, like TensorFlow or PyTorch, they can read the standard by the formats from our output as the input of theirs. Yeah, and for the production ops, actually, I believe this is really helpful. Yeah, especially like the monitoring. Actually, our solution is totally based on the Prometheus and the Grafana. Yeah, so I suggest if you are trying to when you are trying to integrate OpenMLDB into your MLOps, you may first take a look at our connectors for the online data source and also for the production ops. Yeah, then let's see if you have any problems. You can ask us.
Okay, thank you, Dr. Lu, for your answer. And another question from the audience is, could you please introduce a use case or scenario where OpenMLDB is applied?
Today, actually, yeah, before open source info paradigm, most of our scenarios is focusing on like the anti-fraud, like the risk control. Let's say most of these are this kind of scenario, and some scenario like the personal recommendation, basically it's like recommendation. Yeah, and after open source, actually we see most of the applications are also from these two categories. This is probably, I believe these two categories are they really need real-time features. Yeah, and also we also see some potential applications from other domains, like the IoT. Yeah, they actually needed to process quite a lot the time series data. Yeah, so they are also trying to use our OpenMLDB to process this time series data and do the feature computation. Yeah, so I believe as long as we have if we have more users from the community, I believe there will be more applications. Yeah, so you are very welcome to discuss with us about your application.
Okay, so thank you again, Dr. Lu. Yes, thank you for your presentation. And for now, I saw Ms. Qin Sisi is with us again. So, Mr. Qin, you want to continue with your slide?
Yeah, okay. Can you hear me?
Yes, we can hear you and also see your presentation here. So please continue.
Okay. I'm so sorry for that. Maybe there are some problems with my internet connections. So I will continue the left slides of my presentation. And let's see the prospect. I think the prospects are 4 parts. The first one is model governance. I think is more and more important. And the second one is digital assets, including features, models, data, pipelines, etc. Need to be centralized and unified in the management. And the third one is trustworthy AI, making AI more explainable, fair, robust, private, and transparent is an important direction. And last one is make the model monitoring maintenance to be a full life cycle efficient system. And because in the training phase, testing phase, and the production phase, we should evaluate the models and get the feedback for improving. So connecting different phases of evaluating to build a full life cycle of evaluating and operations is necessary. Okay, that's all. That's all my sharing, and I think artificial intelligence has entered thousands of households, and MLOps will enter thousands of enterprises in the near future. Thank you for your listening. Thank you.
Okay, thank you, Ms. Qin. So, yeah, to the audience, do you have any question for the presentation from Ms. Qin on the topic MLOps? Let's see. Yeah, we have one question from the audience. Could you talk more about the MLOps standards and how do the organization use these standards? Ms. Qin?
Yes, okay. Thank you for this question, and I will answer it. I will skip to that slide. These standards. These standards, we also can say MLOps capability maturity model. And actually, we had organized more than 13 excellent companies in China to establish the maturity model, which includes many best practices. And the model aims to help organizations to build or improve their AI capabilities. And maturity level can be regarded as a degree of organizational AI models producing process quality. Different organizations could use different maturity levels to measure their capabilities and to improvement plans and to make improvement plans. The first one, such as the level 1, is for organizations which are in the beginning of using AI. They just want to produce some models successfully for the business, no matter the process. So they could see the level 1 initial level. And when the organizations had developed all models for a while and had met many problems, such as the period is too long or the roles and the teams in the process are complicated, the management is confusion. So they could use level 2 to build the regulations and norms to unify the models producing and operating process and make the initial workflows and version management of some important assets. And the level 3 could be used to help organizations to improve the automation capability and achieve the traceability of the most assets, the workflows, reuse, and the sharing. The level 4 means high-level automation and the workflows of CI, DCTCM should be connected efficient. And then meanwhile, our CNICT also provide appraisals and consulting for the organizations applying this maturity model. That's my answer of this question.
Okay, thank you, Ms. Qin Sisi, for your answer. So thank you for your presentation. And we also got one question for Dr. Lu Mian. So Dr. Lu Mian, here is your question from the audience. Yeah, what are the most popular use cases of OpenMLDB? So Dr. Lu?
Yes.
The question is for you. Yes, we can hear you. And the audience ask what are the most popular use cases of OpenMLDB? Since you already introduced with us several use cases and scenarios. So here is the question.
Yeah, sure. Actually, I believe the most important application is still like the anti-fraud, especially from like the bank, like the fintech companies. Actually, we see quite a lot of use cases from this kind of category. Yeah.
Okay. Thank you, Dr. Lu Mian. Thank you for the answering. And well, let's move on to our next speaker, who is also our last speaker for today's webinar. And I'm happy to invite Zhao Xiaoyong. So he is a principal data scientist working in Microsoft Asian team. And his background is mostly in distributed machine learning and its application, as well as MLOps infrastructure, including future store. And his topic for us today is Feather, high performance future store. So Mr. Zhu Xiaoyong, the floor is yours.
Thank you. Thanks,
Thank
everyone.
You,
let me share my screen.
Okay.
Hi, everyone. My name is Xiaoyong, and I'm a data scientist working in Microsoft. Today, the session is about Feather, an open source, enterprise grade, and high performance feature store. It's an open source feature store, and all the source code, they are available in GitHub, so folks feel free to check it out. Feather itself is built in LinkedIn and Microsoft for many years, used LinkedIn in production for more than 5 or 6 years. And recently, like in April, we open sourced Feather and received a lot of community feedback, and a lot of the customers start to adopt it. And just a couple days ago, we actually donated Feather to Linux Foundation of AI and Data, so that now it's operating under the AI Foundation. So here's the agenda for today. First, I want to talk about why we want to build Feather and feature store in general, and we also want to talk about what should the feature store look like in enterprise setting, and talk about the use case for Feather in LinkedIn, and talk about the Feather integration with Azure with the demo, if we have time. So the first part is on why we actually want to build Feather, because getting features into machine learning models should be easy, and that's what everyone wants. But that's actually not true before feature store was introduced in the community. So the concept there, or the analogy there, is that like feature store or something, it's probably like a music streaming app. So if you, like 20 years ago, if you want to download some music from internet, the workflow there is that you need to manually get the music files from various sources, probably through some search engine, through Yahoo, or through a couple of private websites. And then you need to convert them to a format that the device can play. Maybe it's MP3, maybe it's AAC, maybe it's other formats. And then somehow you need to somehow load the format, load the file itself into like your specific device. Sometimes it's your home device, sometimes it's your car device, and you need to burn a CD, right? And then you also want to worry, you probably also need to worry about the storage, the bit rate, the compatibility, because you're not sure like which device can play which kind of music. So that was like 20 years ago, prior to like all those streaming apps. But now no one is doing that, right? So basically now what you do is that you just ask like Alexa to, hey, Alexa, just play some song for me, right? And if you just somehow figure this out through some streaming app service and just play the song for you. As the end user, you actually don't care about how Alexa works or how the streaming, the music streaming service works. You just know that, you know, I want to listen to this music and that's it. That's actually a good analogy for why feature store, because prior to feature store, the machine learning feature workflow is like this, where folks need to write a lot of jobs to get the entity data from different sources. Sometimes you want to get the user data, sometimes you want to get the product data, and sometimes the data is in SQL Server, sometimes the data is data lake, sometimes it's in like streaming sources like Kafka. Right, there are a lot of different sources for data, which is similar to like a streaming app where you need to download from different websites. And then you need to, as a developer, you need to do some sort of work there. You need to extract the data from somewhere. You need to extract features from the source data. You need to aggregate the data. You need to join them across different data sets. You need to convert them into a proper format, which is the same as in the streaming app. You need to convert different formats into MP3 or AAC. And then you also, in machine learning workflow, you also need to, you also want to load the data into a specific model framework. Sometimes it's TensorFlow, sometimes it's ONNX, sometimes it's PyTorch. And those models could be different between training and serving environment. Right, and that's similar to like how you actually load the music files into your specific device. And the last part is that you also worry about scalability, performance, and when you join different parts of data, you also care about like how actually to solve the data the data scale problem. You care about data leakage. You care about like whether a certain feature is not available in the serving environment, so I need to retrieve it from the training environment again, and that caused a problem. We call it like train serve skill. So there are a lot of problems there where, you know, in the machine learning system, you have a lot of similar problems compared with what you had for the music apps a couple years ago. But now with the feature store, all that problems, they're gone. In a feature store, with the feature store for the feature consumer, they just, you know, they can just import the feature by name, saying, hey, I want this total spending for a certain customer. And I just, I know the name of the feature and I just retrieve it from the feature store. And that's it. I don't care about how the feature is defined, how the feature is calculated. I just know that it is there, right? So if the feature is there, we just import the feature by name into the model's code. If the feature doesn't exist, we will just ask the feature developers to develop it through the simple APIs. That's the analogy between a feature store versus a music app, where that really helps the machine learning engineer to use the features in a more seamless way. So how, just to level down a little bit, so how that actually works is that, let me open the laser pointer. So prior to feature store, usually we have two pipelines. The first pipeline is machine learning model training pipeline, where we have label data, and then we need to build the feature. We need to have the raw feature data, and we need to do a lot of transformation, aggregation, and then do point-in-time joins with the label data, and then train the machine learning models. And put them, after we have the model, we put them into an inference service or into a production service. And after that, whenever we have request data, the data will come here and predict. So that's like a long workflow. And folks need to deal with the raw data, transformation, aggregation, point-in-time joins, online, how to transfer data from raw data to like online storage, all those kind of complex things, and no one is willing to do that. You know, in computer science, there's a famous saying, which is, you know, like every problem could be solved by building another level, of abstraction. That also applies here, where by using feature store or use feather, we don't have to deal with all those kind of complexities. What we want to do is just to simplify it, where we are saying, look, we have the label data, we have the model training process, but now in this raw data part, you don't have to care about all the complex transformation, aggregation, point-in-time joins, how to transfer data from online, offline service. All of those problems can be solved by feather or feature store. And as the end user, you don't, as the end user, just as what you use streaming apps, you just search by the name of the song. In feather or in feature store, you just search by the name of the feature, and you can directly use it without knowing how it's actually being implemented. That's the beauty of feather and feature store. So that's why you know, feature store is an important part in MLOps, because when you actually write code, especially when you write Python code, you just import a different module saying, hey, import module 1, module 2, and module 3. And in feather and feature store, you can just say, look, I want to get those features. I want to get feature 1, 2, and 3, 4 without caring about the details in the names. So that's the high-level concept for feature store. And the feature store principal use cases in LinkedIn and Microsoft is that, first, we usually develop a lot of features. So the features needs to be developed and based on the raw data using very simple and abstracted APIs. And folks also can deploy the features into production, so that after training the machine learning models using those features, the features can be deployed to a production environment as soon as possible. You also need to manage the features so that you can monitor the feature health, monitor the usage of the features, and share the feature across different teams. Those are the principal use cases for feature store. So from the conceptual point of view, there will be two two personas here. One of the persona being the feature producer, where the job of the feature producer is that they'll just develop the feature based on the raw data sets. They probably need to define the sliding window, the aggregation, the transformations, the lookups, and the joins. That'll be the important part of the job of the feature producer. And they also need to develop a feature based on the other features. For example, there are like base features somewhere, and then people will just go there saying that, hey, those base features, they're great, but I also want to build some other features on top of the base features. So we call it derived feature in feather. But basically, that's also the job of the feature developer or of the feature producer. So that's the first part, and then you know, those are the guys who work with the feature store every day. But there are also folks who work with who are the consumer side. In the consumer side, they usually get some features outside of the feature store, just as you use the streaming app, the music streaming apps. So in that case, they don't care about how the feature is defined. They just use the feature as is. What they do is that they use the feature, they join the feature to their training set, they backfill the historical values of the features with the point-in-time correctness, and they also want to efficiently compute and store and serve those features for online inference. So we talked a lot about feature store and feather, and there are a lot of use cases for feather in LinkedIn. For example, you use the label data. You use the label data service. You have the label data, and feather is supporting like all the model training and model development and feature data there. For example, if you go to LinkedIn, it will recommend you a lot of jobs. And all those recommendations, they are based on Feather. It will give you a connection recommendation. For example, this you might be interested in this guy and send him a note or something. So that recommendation is also based on Feather. And whenever Feather is also supporting a lot of the anti-abuse use cases within LinkedIn. For example, if you are trying to spam the service, you register a lot of the emails with the same profile or similar profile. LinkedIn can verify that, can see that very quickly through Feather and through the feature store service. So all those kind of recommendation, anti-abuse, and other services, they are all based on Feather. So currently it's supporting hundreds of models and thousands of features and many kinds of entities. We call it economic graph, where you can basically see a lot of have a lot of you can see the connections between different people and the supporting like petabyte scale of data. The timeline, we also listed the timeline on the right. So in 2017, actually in 2016, the idea began to bloom within the team, and starting from 2017, we started the initial development, and starting 2019, starting from 2018, we start to see a lot of the adoptions. And starting from 2020, majority of the LinkedIn machine learning applications, they are built on Feather. Starting from 2022, like LinkedIn and Microsoft's Azure team, we collaborated a lot to open source Feather, and recently we just joined the Linux Foundation for AI and data. That's sort of the high-level timeline for the project. So the impact in LinkedIn can be measured in 3 aspects. So first, Feather improved a lot of the productivity. So it enables faster experiments with the new features from a couple of weeks to a couple of days. And also it improved a lot of the performance. Like compared with some customized pipelines using Feather, the performance can gain as much as 50%. And eventually, and also it improved a lot for the collaboration between different data scientists and different team members, so that the applications can be shared, because the applications can share different features, and that was very difficult prior to Feather. We still have a couple minutes, so let me show the quick architecture for Feather and a quick demo. So here's the architecture for Feather, where there are as the end user, there are two parts that users can use. The first part is through the Feather UI, where it's high available on Azure resources, and can be explored. And it's also like Feather is also available in Python formats, so that you have like Python APIs, and Feather supports different online and offline stores. For example, for offline stores, it supports like data lake storages such as blob storage or data lake storage or S3 or Delta Lake. So all those kind of data lake formats. It also supports like structured data in like MySQL or SQL Server or Snowflake. And also it supports like streaming sources, for example, like Event Hub and Kafka. Those are the supported sources from the ingestion point of view, and the centralized part is like a Spark engine. So Feather use Spark as the centralized place to calculate all the features. So currently it supports Databricks and Azure Synapse. And then you can materialize the feature into an online store. For online store, it would be like Redis or Cosmos DB. All the credentials can be stored in a secure way. So currently Feather supports like Azure Key Vault and AWS Secret Manager. So all of those resources, they could be provisioned in the cloud. And in Feather, we also have like we also centralize everything into a centralized registry, so that the features can be registered and shared. So the registry, we support like Apache Atlas and the SQL database. And after that, when you actually want to use those features, the features can be used in Jupyter notebooks, in like standard Jupyter notebook, or like Databricks, and in Azure Machine Learning. So those are like just the standard notebook services. So that's sort of the brief architecture for Feather. Let me jump into a quick demo. So seems like I only have like around 5 minutes. So most of the demo content, they are available in the Feather website. I'll just simply go through the feature consumer experience. Basically, in this example, we are going through like a workflow where we have some observation data, which contains users and products. And eventually, what we want to do is that we want to get the features that's defined in a few other tables. For example, we have a table called user profile, mock data. We have the user purchase history data, and we have the product detail data. So what we want to do is to use this centralized observation data and join it on the other tables. That's basically this demo is about. So in that case, what we want to do is that we just define, import a couple of the APIs in Feather, and specify the endpoints that we are going to use, whether we want to use Synapse or Databricks, and what kind of pivot we want to use. And then specify the settings for the endpoints, because Feather uses open architecture, so you need to let Feather know what kind of environment we are using to run this demo. And then initialize the Feather client. Take a look at the data sets that we just talked about. So we have user ID, product ID, timestamp, and some product rating. We can also look through the user's data like this. We can also look through the product data like this. So after that, what we want to do is that, because someone have actually defined all those features in Feather, and from the feature consumer point of view, what we want to do is that we just want to reuse those features directly. In that case, we call this API, which is get features from registry, and then specify the product name. Feather will download all the feature definitions from the cloud or the registry to your local environment. And after that, you actually don't have to. We also have a UI to let you to explore what features they are available there. But you can just go through. But after that, you just need to specify the feature name. For example, you are interested in the user's age, the text rate of the user. For the product, you also interested in quantity and price. So all those, they are just you can just specify it by name, and then Feather will get those for you. So basically, Feather will kick off a job and submit the job for you, and then you can get the result like here. So after that, basically what you see is that aside from the raw data in the observation data, you all the features that are retrieved for you automatically like this. And it's also have like pointing time correctness, and also doing a lot of aggregation. For example, like sliding window for like the user's purchase in the last 90 days. All of those, they are available. And then you can just train a machine learning model and materialize the feature to like an online store such as Redis. After you materialize the feature, you can also get the features from the online store like this, so that like all the features can be accessed in the online setting very easily. That's sort of the quick demo, like a third of the demo that I want to show, but due to the time constraints, there are a lot of things that I can't do here. So folks, feel free to check out the Feather website to see a more complete demo. To wrap up, so there are more resources. First, feel free to check out the source code. Welcome to Star and fork it. And also there are like a lot of tutorials in the GitHub repository. So if you use Slack, feel free to scan this QR code so that you can join our Slack channel. And on the upper right, this is also my personal WeChat. Folks, feel free to connect.
Okay,
right,
thank you.
All. Thank you.
Yeah, okay, thank you, Mr. Zhu Xiaoyong. So I have a question for you. In your slides, page 10, you mentioned about the future store principal use cases, and one of them is manager features. And here, monitor feature health and share across teams. So I wonder, would you like to see more about how the Feather can share across the teams? Are the teams external teams or the internal teams? So that's my question.
Yeah, that's a good question. So I didn't get a chance to show that, but basically Feather supports, we have like a role-based access control. Basically you can share all the features can be registered with a certain employee's name, and then that features can be shared in the Python API, just as what I just showed here. Someone might have registered the features. Let me see. I have someone might register feature. After they have defined the features, they can just register feature using this API. And for example, like I am registering my feature, and those features will be registered in the centralized registry and can be shared across different teams. And the other team member, they don't have to know the details there. They just call a different API, which is get features from registry, this API. So that's how the feature can be shared across different team members.
Okay, so thank you for your answer. So to the audience, do you have any question for this topic, Feather? So you can ask from the neural network, and the ITU staff will transfer the question to the chatting box. Okay, so I got one question. It seems that many future stores are thriving. What is the key advantage to use Feather? Yeah, Mr. Zhu?
Yeah, that's a good question. Let me actually stop sharing. There are a couple of things for Feather. So first, it's built as an open architecture. We call it like a virtual feature store. So the goal is to integrate with many of the major cloud providers and online offline stores. So in that case, as you can see, every component in Feather is pluggable. Like you can, like for offline store, there are many options, and you can choose the one that you use most. And for the online ones, there are also a lot of those options. So that's the first part. And the second part is that it's actually battle tested in Linux and Microsoft for many years, and it's enterprise ready. There are a couple of things that's very unique to Feather. For example, like role-based access control and key vault service integrations. They're all very important for enterprise customers, because enterprise customers require compliance, security, and a lot of things. And there are also like a few very unique things in Feather. For example, like derived features. I didn't get a chance to talk about it, but basically you can build features on top of the other features. So in that case, it really encourages feature sharing across different teams. So yeah, basically to sum up, like Feather is open architecture and enterprise ready. I think those are the biggest sort of selling point for Feather.
Okay, thank you, Mr. Zhu, for your very detailed answer. So for the time reasons, we will deal here with the last question for Mr. Zhu from the audience, Daos. Can you give examples of the derived feature which encourage customers to build on existing features and promote reuse?
That's a good question. So I didn't get a chance to show this in the demo, but since you're asking, let me just show it quickly here. so for derived features, that's more for the feature producers, where, for example, feature producers, they will define a lot of the features. For example, here's an example where feature producer might define something like the product price or the product quantity, all those kind of features, right? And then some other team members might say, look, they are all great features, but what I really want to do is that I probably want to do something else on top of the existing features. In that case, for example, some of the other team members, they define two features called the user skip card balance and whether user has a valid credit card or not, right? So those are the predefined features. And then for another user or feature consumer, they say, look, those features, they're great, but I want to know the features total purchase power. So instead of going back to the original feature and modify the original feature, what he can do is that he can just define another feature called users purchasing power, which is based on the two base features. Those two base features, they are already registered and defined, and then I'm building a derived feature on top of those two features, and then I can do I can do some transformation there. I can like the definition for this purchasing power is that it can be like the gift card balance plus whether the user has a valid credit card or not, right? So in that case, we have like folks focus on building the base features. We also have folks who folks who want to build like derived features, and that's how it works in Feather.
Okay, thank you again, Mr. Zhu, for giving us this interesting talk today. So we are at the end of the hour, and I'd like to close today's webinar. Although we have challenges to address the difficulties on the way to future AI, I think we never stop looking for the better solution. So that's the spirit of us. We are grateful for your time and for this really amazing talk. Also, I'd like to thank the ITU staff who was helping in the back end making this work. And there will be a poll on the neural network of ITU to see if the attendees would recommend AI for Good webinar. For that, help us to evaluate. Also, we will have another webinar on November 21st. So please check out the website and have a great rest of the week. See you next time. Goodbye.
Participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. You can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. After the networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.